In this video, we'll identify key information about the graph of y equals negative 3x squared plus 6x plus 2. We'll then use this information to create a table of values and sketch the graph of this parabola. To get started, the first thing we're asked to determine is if this parabola opens upward or downward. And the part of the equation that we use to determine this is the coefficient on x squared. We can see that in y equals negative 3x squared plus 6x plus 2, that coefficient on x squared is a negative 3. So this parabola opens downward. And we know that because a is negative 3. Now, I referred to that as a. In general, when we're looking at a quadratic equation in two variables, the coefficient on x squared we refer to as a, which is a value of negative 3 here. The coefficient on x we refer to as 6, and that constant term we'll refer to as c. These will be helpful in determining the information for this problem. So I've written them down. A equals negative 3, b is 6, and c is 2. And again, that parabola opens downward as that value of a is negative 3, and anything negative on x squared tells us that the parabola will open downward. The next thing we need to do is find the vertex. To determine the vertex, the x-coordinate will be x equal to negative b over 2a, and that a and b are the ones that I just referred to that correspond to the coefficients. So x equal to negative b over 2a, we can replace a negative b with negative 6, and that's over 2 times negative 3. So we now have negative 6 divided by negative 6, which is 1. So the value of x for our vertex will be 1. To find the value of y, we will replace x with 1 in that equation. So y will equal negative 3 times 1 squared plus 6 times 1 plus 2. And that value will be negative 3 plus 6 plus 2 when we simplify it, and that's simply positive 5. So our vertex we can write as the point 1, 5. Now we're ready to create a table of values for this equation, and we'll use the vertex to determine the x values in our table. So let's make a quick table. And we know that there's symmetry around the vertex, so we're going to make that x value of the vertex the middle of this table. So I'll have x and I'll have y, and I know that when x is 1, y is 5, and I'm going to put a star by that because I have symmetry around it. So I want a couple points to the left and a couple points to the right in order to create this graph. So a couple x values to the left of 1 will be 0 and negative 1, and to the right I'll have the x values of 2 and 3. Now, to find the corresponding y values, I'll replace that value of x into my original equation. So for x equals negative 1, if x is negative 1, then we know that y will be negative 3 times that number negative 1 squared plus 6 times negative 1 plus 2. And that makes y equal to negative 3 times a positive 1, as when we square negative 1 we get positive 1, plus a negative 6 plus 2. And that's simply negative 3 minus 6 plus 2, which is negative 7. So the value of y when x is negative 1 is negative 7. We can do something similar if x is 0. So if x is 0, I will replace x with 0 in that equation. So if y equals negative 3 times 0 squared plus 6 times 0 plus 2. And that will simplify simply to 2. So when x is 0, y is 2. Now, because that vertex lies on the axis of symmetry, I don't actually have to plug in these values of x for 2 and 3. I know, based on the symmetry, that when x is 0, that's 1 unit to the left of 1. If I go 1 unit to the right, I'm going to have the same y value. So when x is 2, y is also 2. And similarly, when x is 3, y will be negative 7. Now I'm ready to sketch the graph of this equation. To start, I'm going to label each of my axes with an x and a y, and then I need to give each of them a scale. I need the x values of negative 1 through 3 to fit on here, and I need the y values. I see that the lowest is -7 and the highest is 5. So I'm going to label this x-axis, and I'll make every two little squares here worth 1 unit. So at the second tick mark I'll label a 1, at the fourth I'll label a 2, and then a 3, and then a 4. And I'll do the same thing in the negative direction. I'll go 2 units to the left and label a -1, 2 more and do a -2, a -3, and then a -4. For the y-axis, I'll simply make each tick mark there worth 1 unit. So at the second tick mark I'm going to label a 2, and then a 4, 2 more units, and then a 6, and then an 8. And then I'll label off -2, -4, -6, and -8. Now I'm ready to plot my points. I'm going to start with the vertex. So that's at the point 1, 5. So I'll go to where x is 1 and y is 5, and I'll plot my point. I know that's going to be the highest point on the graph as this parabola is opening downward. Next I'll graph the point 0, 2, and then I can go 1 more unit to left. I can go -1, -7. And continuing on the right side, I have the point 2, 2 from that table, and then 3, -7. And now that I have each of these points graphed, I'll connect them with a smooth curve that opens downward. And adding arrows to the end to show that this graph continues downward, that completes the graph of this parabola.